A meteorologist who spends his entire career tracking severe weather just issued a warning that stands out even by his own standards. The kind of forecast that immediately grabs the attention of anyone who has followed his coverage closely throughout the year. Not because one single storm is approaching. Because the atmosphere itself is doing something genuinely unusual. Mixing intense heat, sudden cool air, wildfire smoke, flooding concerns, and repeated chances for severe thunderstorms into the same stretch of days across different parts of the country. Shifting from region to region fast enough that a quiet afternoon in one city tells you almost nothing about what is happening. 2 states over, a genuinely difficult picture for anyone to follow, using only a single local forecast check each morning. Meteorologist Max Schuster, host of the Max Velocity Severe Weather Center, described the pattern developing right now in blunt, unmistakable terms. A fast-changing setup capable of gripping the entire country at once. That framing, gripping the entire country rather than threatening one specific region, is precisely what separates this forecast from the kind of localized severe weather warning most people are used to hearing. A typical severe weather alert tells residents of a specific state, or even a specific county, what to expect over the following day or two. A forecast, describing a pattern capable of affecting the entire country simultaneously, just in wildly different ways depending on exactly where you happen to be standing, is a fundamentally different kind of warning. One that requires understanding the broader atmospheric mechanics, driving the whole system rather than simply checking a single local forecast and assuming that tells the whole story. Today, we are going to walk through exactly what is driving this pattern, why so many genuinely different hazards are erupting from the same broad atmospheric setup, and why a pattern this scattered and unpredictable is actually harder to prepare for than a single well-defined storm moving cleanly across the map. If tracking real, current severe weather forecasting, not just the alarming headline version of it, is something you want to keep doing, subscribing means you catch every update the moment new information comes in. Let's start with how this specific pattern actually begins, because the sequence of events matters for understanding why it escalates the way it does. The first major feature to watch is a strong disturbance emerging out of the Rockies, expected to move into the northern plains and Midwest early in the week, setting the stage for everything that follows across the rest of this genuinely unusual stretch. The disturbance is forecast to drag a powerful cold front across the region behind it, and the environment ahead of that front is exactly the kind of setup capable of producing damaging winds, large hail, and possibly an isolated tornado. This is not, on its own, an unusual kind of severe weather event. Cold fronts sweeping across the plains and Midwest produce this exact combination of hazards regularly throughout the summer. What makes this specific week different is what happens after that front moves through, because the broader pattern does not simply reset to calm once the initial disturbance clears. A typical summer cold front follows a relatively predictable script. Ahead of the front, warm, humid air fuels a line of thunderstorms capable of producing wind damage and hail, and behind the front, cooler, drier, more stable air moves in and effectively shuts down the severe weather threat for at least a few days, while that fresh air mass settles into place. The predictable reset is precisely what is not happening this week. Instead of that familiar quiet period following behind the front, an entirely separate feature, the expanding heat dome, is already positioned to take over as the region's next source of severe weather energy almost immediately, denying the affected region the kind of genuine recovery window a summer cold front usually provides. Later in the week, according to Schuster's forecast, the picture becomes considerably more complicated as a heat dome expands eastward from the west, supplying additional energy for a fresh round of storms across the central and eastern states, layering yet another distinct hazard directly on top of whatever the initial cold front has already left behind. A heat dome is a large area of high pressure that traps warm air beneath it, and as that dome expands and shifts position, it does not simply bring heat wherever it moves. It also reshapes the broader steering pattern for storm systems trying to move through the same general region. Disturbances riding along the edge of an expanding heat dome frequently encounter exactly the kind of sharp temperature, contrast, and available energy needed to fuel fresh, severe weather, meaning the heat dome itself becomes an active participant in generating new storm chances, rather than simply sitting passively in place while unrelated storms happen to pass nearby. Picture the heat dome as a large boulder sitting in the middle of a river, forcing the water around it to follow a completely different path than it would have taken otherwise. Storm systems cannot easily push directly through a strong dome of high pressure, since that dome is defined by sinking, stable air actively resistant to the kind of rising motion a thunderstorm needs to develop. Instead, disturbances get deflected around its edge, and it is specifically along that edge where the hot, stable air inside the dome meets cooler, more unstable air outside it, that the sharpest temperature contrasts in the entire regional weather pattern actually develop. That boundary becomes a genuinely favorable zone for severe thunderstorm development, not despite the heat dome's presence, but specifically because of it, which is exactly why an expanding heat dome can end up supplying the energy for an entirely new round of storms, even as it simultaneously brings record heat to the communities sitting directly beneath it. This is precisely where the wildfire smoke enters the picture, and it is worth understanding clearly. Because wildfire smoke and severe thunderstorms can seem like two completely unrelated weather stories until you trace them back to their shared root cause. Exactly the kind of connection this video is specifically designed to draw out. The same persistent heat and dryness responsible for expanding that heat dome across the west is simultaneously the exact combination worsening wildfire conditions across the same region, drying out vegetation and creating the kind of explosive fire behavior that has already defined a severe fire season across states like Washington and Oregon this year. Smoke generated by those fires does not stay confined to the fire zone itself. It drifts downwind, sometimes for hundreds of miles, affecting air quality across a much broader stretch of the country than the fires themselves ever physically touch. Wildfire smoke travels so effectively across long distances because the finest particles it contains are light enough to be carried by upper-level winds well above the fire itself, riding along the same general atmospheric currents responsible for steering weather systems across the country. Once lofted high enough into the atmosphere, that smoke can travel remarkably efficiently, sometimes reaching a cities 1,000 miles or more from the nearest active fire, while still degrading air quality to genuinely unhealthy levels for sensitive groups. That is precisely why a wildfire burning in one part of the West can end up directly contributing to a hazy, unhealthy air quality day in a Midwestern or even East Coast city that has no active fire anywhere near it. Another example of how this week's pattern connects seemingly distant regions through the same broader atmospheric transport system. Wildfire smoke and severe storms are, in this specific pattern, not two separate stories sharing a news cycle. By coincidence, they are two different consequences of the exact same underlying heat and dryness driving the broader atmospheric setup. That connection extends further than simply sharing a root cause, since smoke itself can measurably influence the atmosphere in ways that feed back into the broader pattern. Thick smoke plumes can partially block incoming sunlight, subtly cooling the surface temperature directly beneath them even during an active heat wave, while simultaneously altering local humidity and stability in ways that can either suppress or, in some cases, help organize thunderstorm activity along the smoke plume's edges. Researchers studying the interaction between wildfire smoke and severe weather have found that these effects, while genuinely complex and still an active area of study, are real enough that forecasters increasingly have to account for smoke transport alongside more traditional variables like temperature, moisture, and wind shear when trying to predict exactly how a pattern like this one will actually behave day to day. Layer all of this together, and you get exactly the kind of scattered, hard-to-summarize week Schuster's forecast describes: cool relief arriving in some areas as the initial cold front clears, punishing heat building in others as the heat dome expands, wildfire smoke degrading air quality across a wide downwind stretch, and repeated chances for damaging winds, large hail, flooding, and possibly tornadoes, as new disturbances continue riding along the shifting boundary between all of these competing air masses. A genuinely difficult picture to summarize in a single sentence or a single regional forecast. None of these individual hazards is unprecedented on its own. What makes this pattern genuinely unusual is how many of them are unfolding simultaneously, feeding off each other and shifting geographically fast enough that no single region gets to experience just one hazard in isolation. It helps to understand exactly why a pattern like this is so much harder to prepare for than a single, clearly defined storm system. Because the difficulty is not simply about the number of hazards involved, it is about how quickly the specific danger shifts from place to place. A single hurricane or a single well-forecast tornado outbreak gives residents in its path a reasonably clear, sustained window to track its approach and prepare accordingly. A rolling, multi-hazard pattern like this one behaves differently. The greatest concern on any given day can shift entirely to a new region within 24 to 48 hours, meaning a community that experienced calm weather yesterday cannot safely assume today will look the same, and a community bracing for one specific hazard, say severe thunderstorms, may find itself dealing with a completely different one, like sudden wildfire smoke, arriving from an entirely unexpected direction instead. That kind of rapid regional handoff creates genuine challenges for public communication as well, beyond just the meteorological complexity itself. A single, well-defined storm system generates a single sustained news story that residents can follow continuously as it approaches, peaks, and passes. A rolling pattern like this one generates a constantly shifting set of regional stories, each relevant to a different part of the country at a different moment, making it considerably harder for any single resident to maintain a clear, continuous picture of what actually matters for their own specific location without checking updates far more frequently than they might during a more conventional single storm week. This is also exactly the kind of pattern where relying on a single national news source can genuinely leave you less informed than checking a dedicated local forecast directly. National coverage of a scattered multi-region pattern like this one has to make editorial choices about which specific developments to feature at any given moment, inevitably leaving some regional stories undercovered simply due to limited airtime or column space, even when those undercovered regions are facing a genuinely serious version of the broader pattern's hazards. Local National Weather Service offices and regional meteorologists, by contrast, remain focused entirely on their own specific coverage area throughout the entire pattern, making them a more reliable, consistently updated source for exactly what this week's setup means for your own particular location. This specific challenge is exactly what meteorologists mean when they describe a pattern as active rather than simply severe. An active pattern is not defined by any single catastrophic event. It is defined by the atmosphere's overall willingness to keep generating new hazards across a wide geographic area over an extended stretch of time, rather than delivering one significant event and then settling back into a quieter baseline. Meteorologists sometimes distinguish between what they call a pattern-driven forecast and an event-driven forecast, and the difference matters enormously for how confidently a specific outcome can be predicted. An event-driven forecast tracks one specific system, a hurricane, a defined severe weather outbreak, or a winter storm with a beginning, a peak, and an end that forecasters can identify and communicate with real precision. A pattern-driven forecast, like the one currently unfolding, describes a broader set of atmospheric conditions favorable for generating repeated, evolving hazards over an extended window, without necessarily being able to specify in advance exactly which specific storms will form, exactly where, or exactly when within that broader window. That inherent imprecision is not a failure of forecasting technology. It reflects the genuinely more complex, more open-ended nature of the underlying atmospheric setup itself. That does not mean pattern-driven forecasts are less valuable than event-driven ones, simply that they require a different kind of attention from anyone trying to actually use them to stay safe. An event-driven forecast tells you almost everything you need to know in a single update, since the storm's path and timing are the main variables left to track. A pattern-driven forecast instead tells you the overall shape of the risk, which regions face elevated danger, which hazards are most likely, and roughly what window of time to stay alert during, while leaving the specific day-to-day details to be filled in by shorter-range forecasts issued as the pattern actually unfolds. Understanding that distinction helps explain why this week's coverage may feel less definitive than a typical hurricane or tornado warning, and why staying engaged with updated forecasts throughout the week matters more than usual, given how much of the specific detail is still genuinely being worked out in real time. That distinction matters enormously for how residents and emergency planners should actually think about a week like this one. Preparing for a single storm is, in some ways, more straightforward. You track its approach, you prepare for its specific hazards, and once it passes, the immediate danger has largely resolved. Preparing for an active, multi-hazard pattern requires a different, more sustained kind of vigilance. Since the danger does not resolve once any single component of the pattern moves through, it simply relocates to wherever the shifting boundary between heat, cold, moisture, and smoke happens to be pushing next. There is a broader climate context worth understanding behind why this particular summer has produced so many of these scattered, multi-hazard patterns in the first place. Record or near-record warm ocean temperatures across large stretches of the Gulf of Mexico and the broader Atlantic and Pacific basins this year have provided an unusually large reservoir of heat and moisture for the atmosphere to draw upon, considerably more than a typical summer offers. That oversized energy reservoir does not simply make any single storm stronger in isolation. It increases the odds that multiple genuinely different types of severe weather can draw on that same abundant fuel supply simultaneously, exactly the dynamic responsible for this week's combination of heat, cold fronts, wildfire smoke, and repeated storm chances all converging at once, rather than arriving one at a time with natural spacing in between. It helps to think of a typical summer's available atmospheric energy as a modest, steady stream, generally enough to fuel one significant weather event at a time before that specific reservoir needs time to replenish. This year's unusually warm ocean baseline behaves more like a much larger, continuously replenishing reservoir, capable of simultaneously supplying multiple independent weather systems without either one meaningfully depleting what remains available for the other. That distinction is precisely why this year has produced so many weeks, featuring this kind of scattered multi-hazard complexity, rather than the more typical pattern of one significant event, followed by a genuine lull before the next one develops. Given everything currently unfolding, here is what is actually worth doing to prepare for a pattern this scattered and unpredictable. Do not assume that a quiet day in your specific location means the broader pattern has calmed down nationally, since the greatest concern in a rolling, multi-hazard setup like this one can shift to an entirely different region within a single day. Check your local forecast directly and repeatedly throughout the week, rather than relying on a single check-in, since conditions in exactly this kind of pattern can change meaningfully faster than a typical, more predictable, severe weather setup, sometimes shifting within a matter of hours rather than days. Keep an eye on air quality, specifically if you live anywhere downwind of active wildfires, even if you're nowhere near the fires themselves, since smoke from this pattern's western fire activity can travel hundreds of miles and affect respiratory health well outside any area under a direct storm or the heat warning. And maintain a basic emergency kit ready regardless of which specific hazard seems most relevant to your area on any given day, since a pattern capable of producing damaging winds, large hail, flooding, extreme heat, and hazardous air quality within the same week benefits from broad, general preparedness, rather than narrow planning for just one specific threat. That broad preparedness approach should include supplies relevant to multiple hazard types simultaneously, something worth double-checking now, rather than assuming your existing kit already covers everything this specific pattern could throw at your area. Alongside standard severe weather supplies, water, a flashlight, a way to receive emergency alerts include N95 or KN95 masks in case smoke arrives, extra water specifically for staying hydrated during any heat spike, and a plan for cooling off safely if a heat warning is issued alongside an unrelated severe thunderstorm watch on the very same day, a genuinely plausible scenario given how many different hazards this specific pattern has already demonstrated it can produce within the same short window. What is unfolding across the country this week is a genuine demonstration of how complicated modern severe weather forecasting has become, not because any single hazard is unprecedented, but because so many different hazards, heat, cold, smoke, wind, hail, and flooding, are all drawing on the same unusually abundant atmospheric fuel supply at the same time, shifting from region to region fast enough that staying informed requires genuine, sustained attention rather than a single glance at the forecast earlier in the week, and rewarding exactly the kind of ongoing, active engagement this video has tried to encourage throughout. Meteorologists like Schuster do not reach for words like strange casually, and when an experienced forecaster describes a pattern using that specific language, it reflects a genuine assessment that this week's setup falls outside the range of what a typical summer week usually produces. That specific choice of language deserves some weight on its own. Meteorologists spend entire careers building an intuitive sense of what a typical seasonal pattern actually looks like, developed through years of watching forecast models, comparing current setups against historical analogs, and communicating risk to the public without resorting to unnecessary alarm. When a forecaster with that kind of background specifically flags a pattern as unusual, rather than simply describing another routine round of summer storms, that word choice reflects a genuine professional judgment that this specific combination of factors sits outside the range of what recent years have typically delivered, precisely the kind of signal worth taking seriously even before any single storm within the broader pattern has actually developed. We will keep tracking this pattern as it continues to evolve across the country, since a setup this scattered and multi-directional rarely resolves cleanly within just a few days. If you want those updates the moment they land, subscribing is the way to make sure you do not miss them, since a pattern this active tends to keep producing new developments well past the point most single storm coverage would have already wrapped up. And if you are anywhere in this pattern's path right now, tell us in the comments which specific hazard has actually affected you most: heat, storm, smoke, or something else entirely, because comparing notes across different regions is often the fastest way for everyone else to understand exactly how unevenly a pattern like this one is actually playing out, sometimes days before a national forecast fully catches up to what residents on the ground are already living through. Stay safe, and we will see you in the next one.